All right, we're back again. We're gonna, this time, we're gonna do a little factoring of a special type here. We're gonna start to look at these special types. This special type will look like this: x squared plus bx plus c. This is what we're gonna focus on. So we'll start off with an example. Uh, Now I'm gonna do the opposite of factoring. I'm gonna multiply, just to show you, give you an idea of why we're about to do what we're about to do. So before we actually do the factoring, let's look at a simple multiplication. X plus 3 times x minus 5, for example. Now, if you were going to multiply this, you would start with your x times your x, and be an x squared, and then x times minus 5 is a minus 5x. 3 times x is 3x, and 3 times negative 5 is minus 15. So we'd end up with x squared minus 2x and a minus 15. Now, what you notice going backwards, so in other words, let's say our goal was to factor this. Well, we would first think, okay, well, I've seen trinomials before. Maybe it came from something like this. And I know from experience that if I had an x here and an x here, that would certainly give me an x squared. And I know from experience that minus 15 might come from a 3 and a 5. It might, I don't know for sure. And the middle in here, notice, where did it come from? Well, look. It came from adding the 3 and the 5. Now, the signs have to be correct. So since this is a negative, I got to make one of these here negative, the signs in between here. Well, the answer to that is you look at the two numbers, the 3 and the 5, and one of them will be negative, and you want the sum to be a negative 2. Well, the only way that happens is if you make that a negative and make that a positive. So the things we're looking at here are, when we do this factoring, we need these two numbers right here. We need the product to be this number. So that's how we choose them. We choose them so that the product is this negative 15. Now, it might have been negative 15 and a 1. I didn't know that. But what seals the deal is that we need the product to be negative 15, and we also need the sum to be negative 2 in here. Okay, so we need two numbers whose product is negative 15 and whose sum is negative 2. So you think through your mind, and you come up using your multiplication tables, you come up with those numbers. And I did it. I had negative 5 along with a positive 3. I know that the sum is a negative 2. And the product is a negative 15. So it's all good. So now, usually it doesn't take that much effort and much thought to go through these problems. Let's take another example. Let's start from scratch now. We're going to have, let's say we want to factor this thing. X squared minus 7x plus, let's say 10. Okay. And by the way, when you look at one of these trinomials like this in this form, they're not all factorable. Sometimes they are not factorable. And we'll be able to tell if we fail in our attempt to find two numbers whose product is 10 and whose sum is negative 7. So I start off with an x and an x, that's going to be true. Then I think about the two numbers whose product is 10 and whose sum is negative 7. Now I start with what I'm familiar with, and start with the 2 and the 5, for example. 2 times 5 is 10. But I need this to be a negative 7 when I add these up. If I add them up now, there'll just be a positive 7. So let's make both of them negative. Then the product is still 10, but the sum is -7. So these are the two numbers that I use. I put a -2, I put a -5 like that. So notice I'm using this negative as if it were a minus in my term here, my binomial term, or my binomial factor. Okay, I use a minus interchangeably with a negative, which is fine. It doesn't, I don't lose anything for that. So that's my answer right there. That is your answer. Okay, just like that. All right, let's take another one of these, and then that should be enough for these. Let's try one more. Let's factor x squared minus, let's make it 10x, and make this a, let's see, 7, let's make this a 21. Okay, so we start off, we go with an x and an x. That'll make the x squared. And I need two numbers whose product is 21, but add up to -10. So immediately I go through my times tables in my head, and I think, hey, how about 3 and 7? If I make them both negative, that adds up to -10, and the product is 21. So there I am. Okay, so it's that simple. Let's try another one. Let's factor. Let's do a different variable. How about y squared minus 13y, and then plus a 42. All right, let's see what we have here. Start off with your y and y. Whoops. A y here and a y here. Now I need a 42. First thing I think of is 6 and 7. Guess what? It's perfect. They add up to -13, and the product is 42. It's done. Let's try another one. Let's go u squared minus, let's make this plus 12u, and let's make this, well, let's make it 35, like that. Okay, 35. All right, begin. Gotta have a u, gotta have a u. Now that 35, again, I'm thinking, first thing that comes to mind for me is a 5 and a 7. But I'm very lucky because 5 plus 7 is 12, and I am done. Just like that. Okay. Okay, here we are back again. Factor u squared plus 8u minus 33. All right, so we'll start off. Gotta have a u, gotta have a u. That makes the u squared. 33. Again, I might go with my times tables with an 11 and a 3. I need that to be negative, so one of these has to be negative, the other one positive, and I keep that in mind with the 8 over here. I'm going to need a positive answer, so if I keep this one plus and this minus, then this product will be -33, and its sum will be a +8. So there I am. That's my answer, 11 minus the 3, like that. And then it works. Okay, let's look at one. Here's another one. Let's try this. X squared plus 4x plus 6. Let's try that. Okay, so now you jump back in, got your x and your x. Now I need two numbers whose product is 6, which add up to 4. So I run through, immediately I think of 2 and 3. Now everything's positive here, so I'm going to have positive numbers throughout. But this doesn't work because 2 plus 3 is 5, not 4. So that doesn't work. How about 6 and 1? 6 times 1 is 6. But 6 plus 1 is 7, not 4. I don't have any other choices to get that 6. I can't use anything but integers. I always have to have integers here. So I don't have any integers that's going to make this work. So I'm done. I say, prime, you can't do this problem. Okay, you can't factor it over the integers like I'm trying to do. I can't do it. Okay, so I think that gives you a good sample of those types of problems. I'm going to do one more over here. Okay, just one more. All right, here we are. Again, we'll take one more example. Okay, now we're out to factor this one. If you got your eyes open, you'll notice right away that this one is different from the others because it has a 5 in the front. Okay, it's not like these ones that we just did. So you should think, well, okay, maybe a GCF. Scan across. Yeah, a 5 goes into each of these, so let's pull out the 5. It'd be a 9x, have to be a, what, 22, right? All right, am I done? I don't know. It depends. If I can factor this any further, then that means I'm not done. So I will try to factor this one more step. Let's see. So this would be trying to get a complete factorization. So first thing I do is look for that GCF if there is one. Okay, second thing, I'll try the specialized factoring of this remaining trinomial. I'll go with this and this, and now I need that 22. First thing that comes to mind is negative 11 and a 2. Okay, I need a negative 22, so this will work, and it'll add to negative 9, so I'll write minus 11 plus a 2. Done. Okay. If you really want, you can check this by multiplying this back out and making sure that it equals the original expression. Okay, but we'll call it quits there.